Well, hello, algebra. Here's our do now. Go ahead and solve this one for x. You can hit pause until you got this done, and then I'll reveal the solution. All right, so we just need to undo that one operation in there. The green highlight there is division. The opposite of that would be multiply. So we're going to multiply both sides by -6, giving us a solution, x equals -18. So today we're going to take a look at inequalities. We're going to continue with the same learning target with these 3 tasks we need to accomplish with inequalities. We'll need to be able to write an inequality, graph an inequality, and solve an inequality. The subtitle there, multiplying and dividing, really only applies to solving, which will be different today than what we saw yesterday with solving that used adding and subtracting. So with solving an inequality, the one thing we have to pay attention to is this one thing, which is completely different from what happens when we solve an equation. So anytime we multiply or divide by a negative number, that inequality symbol is going to switch directions. If it used to be a less than, it's going to become a greater than. If it used to be a greater than or equal to, it's going to change to a less than or equal to. Okay, so this only applies when our step that we're taking to solve the algebra is multiplying by a negative number or dividing by a negative number. Just because there's a negative number in the problem doesn't mean we need to do anything. Just if the equation starts out with multiplication by a negative number, that's not when the symbol flips. It's when our process of solving, when we do with a multiplication by a negative or division by a negative number. All right, so let's look at maybe an illustration why this happens. So I have 2 different number sentences that I've graphed on this number line. The left-hand number sentence simply says 1 is less than 7. Okay, so I graphed those onto the number line. They're color-coded, so the yellow is at 1 and the pink one is at 7. And when we look at a number line, the thing we have to pay attention to is that whatever is further to the right, that is the greater. So the pink one is greater, and we know that anyway, but we can see that on the number line, right? When I multiplied both of those numbers by -1 to create the opposite, -1 and -7, when I graph those, I can see that now the green one is further to the right. It is the greater number, right? And so if we didn't change the inequality symbol, like this would make no sense. It would be saying something like -1 is less than -7, and that's not what we see in reality. It's not what's illustrated on this number line. Okay, if you've ever seen Michael Jackson's video for Thriller, the zombies when they dance kind of do something similar here. So of course Michael Jackson always wore a glove back then. So this hand is going to represent that yellow dot that I colored in black, and this one will be the pink dot. Okay, so when we start, and then we switch to the opposites. Here's the starting position, switch to the opposites. So I'm over here, the pink one is further to the right. I'm over here, the green one is further to the right. Yeah, plus it's just a fun dance to do. So let's look at a couple of examples where this happens. Solve this inequality. So we got -2 times x greater than or equal to 6. So in order to solve this, my first step is going to be to divide both sides by that -2. In the opposite operation, when I do that, these -2's will cancel x. And then the other side, 6 divided by -2 is going to be -3. And now let's think about that symbol. What was the operation that I did, that I applied to solve this? The operation I used was division. I divided by a negative number. Okay, when that happens, when I'm dividing by a negative, that's when I need to switch the symbol. So this is going to change to less than or equal to. And when I graph this, I'm going to put a closed dot on the -3. And since x is less than, I'm going to shade towards the left. Okay, solve this inequality. So this time, to do the opposite operation, I'll need to multiply by 2. I have to do the same thing on both sides. These 2's are going to cancel each other out, so I'll get the x. I'll do the symbol afterwards. the numbers. Negative 8 times 2 is negative 16. Now let's think about that symbol. I have my operation was multiplication, but I multiplied by positive 2. Okay, if I'm multiplying by a positive number, nothing happens to the symbol. It does not matter that there's a negative number in the problem and it got multiplied by 2. My operation was multiplying by positive 2. So this symbol is going to stay exactly the same as it was. It was less than or equal to start with. It's going to stay less than or equal to. And so now when I graph this, I'm going to put my closed dot at negative 16 and shade to the left for less than. All right, this time I will have to multiply by negative 3. I'm going to put parentheses around my negative 3 to keep that negative sign attached so I don't get confused with subtraction. So these will cancel. X is going to come down. Let's think about these numbers first. 4 times negative 3 is negative 12. And that symbol is going to have to do what? Does it stay the same? Does it change? Well, my operation was multiplication, and I multiplied by a negative number. So if I'm multiplying by a negative number, I have to change that symbol around. So this is going to reverse course and become a greater than or equal to. And so now when I graph this, I'll put my closed dot at the negative 12, and I'm going to shade to the right for greater than. Okay, so this is a different kind of problem here. This is kind of like what we saw yesterday. So to solve this one for x, so we need to subtract. And when that happens, these 4s cancel. That x comes down. Let's do the numbers first. 8 minus 12 minus 4 is 8. Get ahead of myself there. And so what happens with the symbol? Well, this time, so we got there's a minus sign there, right? But I was not multiplying by a negative. It was not dividing by a negative. So just because there's a negative sign there or a subtract, that does not mean that my symbol needs to change, right? It's, a lot of times we get overzealous and we start swapping symbols when we don't need to. So this one is not going to change because I did not do any multiplication or division. So just x is greater than or equal to 8. And find 8 on my number line. It's going to get a closed dot, and I will shade to the right because this is greater than.